Hello, this is Mr. Henry, and this is lesson 4.1. Today we are talking about plotting points on a coordinate plane. And the essential question is, well, how do I identify and plot points on a coordinate plane? Pretty simple. So before we get to a coordinate plane, which is two-dimensional, let's look at the number line here, which is one-dimensional. So the Get the Groove here wants you to plot these four numbers on the number line. And just by looking at this, I can see that it is clearly not correct because I'm seeing some negative numbers that are bigger than some positive numbers. So let's move some of this stuff around. So first off, let's put 0 in the middle, and then we can move stuff around where we need to. So if 0 is in the middle, positive 4 would be a 1, 2, 3, would be over this way. So 0, positive 1, positive 2, positive 3, positive 4. Now going the other way from 0, we get negative 1, negative 2 would be there. Negative 3, negative 4, negative 5, negative 6. Ooh, it fits. Good. And there is negative 7. So when you're plotting points on a number line, that way is bigger, or you could call them like more positive. This way is smaller, or more negative. Okay? For vocabulary, we've got here 4 vocab words. We've got quadrants, which when you're talking about a coordinate grid, the quadrants are the 4 regions of the coordinate grid. We'll talk about them here in, well, a minute or so. The coordinate plane itself, so we're talking about 4 regions of the coordinate plane. Well, the coordinate plane is made up of 2 axes. So it has the x and the y axis. And an ordered pair is made up of the x, y coordinates, and the x tells you to move left and right, and the y tells you to move up and down. Most of these, in fact all of these, should be old news. You should know these by now. These are just kind of review. So let's see how much you actually do remember. So here we have a graph, and you'll have one of these on your note sheet as well. We want you to locate and label. So you could just draw a line, you could highlight them, whatever you need to do to label the pieces that are under here. So first off, I'd actually like you to do it in pencil or something you can erase with, but try to identify these pieces, draw them, label them, highlight them, whatever you need to do. I'll get my highlighter. And then play, or pause the video, do it, and then hit play when you're ready to continue. Alright, so let's see what we got here. We'll start with that color. So the x-axis. The x-axis is that line. The x-axis is horizontal. That tells you the sideways motion. The y-axis is, oopsie. The y-axis is that line. It is in charge of the up and down motion. Okay, so we've got the x-axis and we've got the y-axis. Let me erase this part. Make a normal line for them. There we go. Y-axis is that. X-axis is that. Okay, origin. Origin is the point in the very middle. It has the coordinates 0, 0. So the origin we would find right there. So this point right here is the origin. And quadrants 1, 2, 3, and 4. Now these are always written in Roman numerals. So if you wrote yours down 1, 2, 3, 4, go back and fix them. They don't belong like that. This is how they're written. Okay, and the way I remember this is I remember it makes like a giant letter C. So when I make a giant letter C, I go like this. 1, 2, 3, 4. So it kind of goes like clockwise starting here. So when you make your giant letter C, this is quadrant 1, Roman numeral to capital I. This is quadrant 2. This is quadrant 3. And this is quadrant 4. So it goes 1, 2, 3, 4. Okay. So this should have all been kind of review. You should have seen this definitely before. But if not, that's a nice little recap for you. The next thing in this entire lesson's review, but the next thing here is we're going to be plotting some points. So underneath my little box here, I have about 6 points. I would like you to graph, and then as you're graphing, connect the dots in order. So here you go. Again, pause the video, try it on your own. If you want to do 1 or 2, and then hit play to see how you're doing, and then pause and do the rest of them, that's a good idea. But try to plot these points right now. Okay, so you should have done this by now, but I'm going to go ahead and get started. So letter A is at 0, 2, so you move sideways 0, up and down 2. So you move sideways none, up and down to positive 2. There is A. Letter B, you go sideways to negative 3, negative 1, negative 2, negative 3, up and down to positive 5. 1, 2, 3, 4, 5. Right there is B. Okay, so done, done. Letter C, sideways to negative 5. 1, 2, 3, 4, 5. Up and down to positive 1. There's C. Let's see, letter D. Sideways to 0, so I'm going to be on this line right here. Sideways to 0, up and down to negative 4. 1, 2, 3, 4. That's letter D. Letter E, sideways to positive 5. 1, 2, 3, 4, 5. Up and down to positive 1. Will be right there is E. And lastly, F, 3, 5. So sideways to 3, 1, 2, 3, up and down to 5. 1, 2, 3, 4, 5. And if you connect them in order, ooey, dun, 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 you get a shape like that, or if you connect them with curvy lines, you get something like that. Kind of like a heart-ish shape. Okay, but this is just practice again, using the x-y coordinate pairs. The first number is the x coordinate, the second number is the y coordinate. The first one tells you how far to move sideways, the second one tells you how far to move up and down. Okay, you always start from the origin every time you graph, and then you move the way it tells you to move. So this one told me to move 3 in the negative direction, 5 in the positive direction, and that's how I got point B. Okay, now the next couple questions come from the textbook, page 206, numbers 1 through 6. I have some of them here, and I have some of them on my next slide. So take out your book, do them, pause the video, and then hit play when you are ready to continue. Okay, let's see here. Number 1 says, use the coordinate plane in example 1, and I have it copied here, to give the coordinate of points, to give the coordinates of points C, D, and E. So they found what A and B were. They did not find C, D, or E, so that is our job. Okay, so letter C. Well, I'd move sideways 0, so as an x coordinate of 0. I'd move up and down 2. That is letter C. Letter D. From the origin, I'd move positive 1, 2, 3, so positive 3, and then in the up and down, positive 1. And lastly, letter E, from the origin, I'd move negative 1, negative 2, and then in the up and down, negative 1, negative 2, negative 3. So those are the coordinates of the points. For those who have a hard time remembering, remember that on that number line we had originally, way back up here, as you go this way, it was positive. This way is negative. It's the same thing on this x-axis. In fact, this is just a piece of the x-axis. So this way was positive, this way was negative. And then as you're doing in the y-axis, the way I remember it is as you go higher up, the numbers are getting bigger, so they're positive. As you go down, the numbers are getting smaller, that's negative. Okay, number 2. What is the y-coordinate of any point on the x-axis? So any point on here, what is the y-coordinate? So if I just make up some point right there, what's the y-coordinate of that point? And the answer was the y-coordinate would be 0. Because you'd move from here, so if I was going to that point, 1, 2, 3, I'd go sideways 4, and then up and down 0. I wouldn't move up and down at all. So it's always going to have a y-coordinate of 0. All right, 3 through 6. They just want you to plot the point and describe the location. I probably don't need all 3 of these. So let's just see. 3. I'm sorry, yeah, number 3 is going to go to point 2, 5. So from the origin, go positive 2, positive 5. 3, 4, 5. That is A. And as far as describing the point, I would call that is in quadrant 1. Q1. Letter B. I'm going to put it on the same graph. I'll just change color. I'm doing green now. So letter B is at negative 1, 0. Negative 1, 0. So I did not move up and down at all. That's point B. And let's see, that's not in one of the quadrants because it's on this black line. That black line is the x-axis. Number 5. I'll do number 5 here. We'll do 5 and 6 on this one. Number 5 has a coordinate negative 2, negative 1. Okay, so negative 2, negative 1. Sideways to negative 2, up and down to negative 1. That's point C. And that's definitely in quadrant 1, 2, 3. This goes 1, 2, 3. So that's in quadrant 3. And lastly, number 6 is negative 5, 3. So it goes sideways in 1, 2, 3, 4. There's negative 5 in the x-axis. There's positive 3 in the x-axis. So that's point D. And that would be 1, 2, quadrant 2. So this was Q2. This was Q3. Okay, so when you're describing a location, you're looking for basically the stuff we did in that first problem. You're looking for, is it the origin, is it the x-axis, the y-axis, which quadrant is it in? That's the kind of information that you're going to be putting down. Okay, number 7 on the back of the note sheet says we want to graph this function with a domain of this, then identify the range. Now, it's been quite a while since we've talked about functions, but this is pretty easy. What we're going to do is we're going to make an x, y table. So, T-chart sort of thing. So I'm going to put x, y. Now, in this problem, it gives us the domain. It tells us what x values to use. It says use these. It means we don't even have to make up our own. We just use negative 2, negative 1, 0, 1, 2. And when we use our own and we plug them in, we're going to get our own y values. So, to find the y value for each of these points, what we're going to do, and maybe you want to do this on the back or on scrap paper someplace, you're going to take each point and plug it into that function. So let me do the first one over here. Watch. It says y equals 2x minus 1. But instead of having an x, if we plugged in negative 2, so 2 times negative 2, and now we just do the math. Look, we have just a y variable. We do not have any more x's, so we just solve. We just do the math on this side. Well, 2 times negative 2 is a negative 4. And negative 4 minus 1 is negative 5. For negative 1. Let's see. So I'm just going to write the whole thing over here, sort of. So I'm going to put 2 times a negative 1, because that's the x part, minus 1. Now let's see if I can do this in my head. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. Okay, so we got a negative 5, then a negative 3. Okay, so what about 0? So 2 times 0 minus 1. Well, 2 times 0 is 0, and 0 minus 1 is negative 1. Okay. Now, I'm going to plot these 3 points first. So let's see here. So if we plot the point, now, look at this. This is literally an xy coordinate pair like you did up here. You plotted those points, just one number than the other. That's what we have. We have an x coordinate is negative 2. So the x is negative 2. The y coordinate is negative 5. 1, 2, 3, 4, 5. That is this first point. The point, now, yeah, that's the point negative 2, negative 5. Now let's plot the second point. The point is going to be negative 1, negative 3. So I go from the origin to negative 1 in the x, negative 1, negative 2, negative 3 in the y. Okay, one more. 0, negative 1. So from on the x coordinate, I go sideways 0, up and down negative 1. All right. Now, I would like you to do these last two. So for positive 1 and positive 2, I want you to plug them into the function, find out the y value, and graph the 2 points. Pause the video, hit play when you're ready to continue. Okay, so let's see. Number 1, you should have 2 times positive 1 minus 1. 2 times positive 1 is 2, minus 1 is 1. And then we take 2 times the x value is 2, minus 1. 2 times 2 is 4. 4 minus 1 is 3. So you're going to need to plot the point 1, 1, and 2, 3. Okay, so you're going to plot 1, 1, and 2, 1, 2, 3. You notice how it makes a nice straight line. That's how most of our functions are going to be. They're called linear functions. They make a line. You don't need to draw the line, because we're only looking at those 5 points, which are just those 5 points. So that problem is done. Now, this last problem we're looking at, example 4 here, what we're going to do is we're going to graph a function represented by a table. So it gives us a table. Now, there's the information for you. We are given a table, and we just want to plot those points up here. Now, before I set you free to do this, just a little bit of a heads up. First off, the top number on a table like this is usually your x-axis. That'd be the sideways. The bottom number is usually the up and down. Also, if you heard of independent and dependent variables, the independent variable goes here, the dependent variable goes there. So the height of somebody depends on their age. Their age does not depend on their height. So this is dependent. And lastly, make sure you use a good scale, because you cannot count by ones here. You're never going to get up to 42 if you go 1, 2, 3, 4, 5. So you need to count by a good scale. Fours, I think, is a little shy, but I think counting by fives would actually be the best option. And over here, counting by ones or something might be sufficient. So go ahead, pause the video, finish up this problem on your own, and then hit play when you're ready to continue. Okay, first off, let me show why counting by like threes or fours won't work. How did I come up with 5? Well, if you would count by twos, just think about this in your head. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We need to get up to at least 42, so 2's didn't work. What if we go up to 4's? 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. We're just a little bit shy. Well, that was pretty close. So then I figured, well, if 4's didn't work, the next best thing is 5's. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That gets us up to 42 right about there. And on this other axis, just counting by ones, because we only need to go up to 5. So 1, 2, 3, 4, 5 works sufficient. Or, if you wanted to space it out a little bit more, you could even go like this. Skip a space, 1. Skip a space, 2. Skip a space, 3. Skip a space, 4. Skip a space, 5. It's really up to you. There's no exact way to do it. I'm going to leave this up here just because I have it here. But if you did it 1, 2, 3, 4, 5, you're just as good. So now you just plotted the points. You went from the x-axis to 1 and then up to 25. And then 2 to 35. 3 to 36. Now, if you don't know where 36 is, it's just a little bit bigger than 35, but not quite to 40. So I'd go right about there someplace. And then 4, 38. That's a little bit closer to 40. 5, 42. It's in there someplace. Now, again, you'll notice this guy is not a line. This was not a linear function. It is a function, but it's not linear because it doesn't make a straight line. It's kind of zigzaggy. You do not need to connect the dots. The point here was just to practice graphing points on a coordinate plane using x and y coordinate pairs, like up here. Okay? The last two problems for the day come from the textbook. This is a nice short lesson. So, problems numbers 7 and 8. Go ahead and do them right now. Okay. Number 7 says, graph the function negative 1/3 x plus 2 with this domain. Okay, so I have my x, y table. That's how we did this before. These are the x values. Domain is x. Range is y. So the domain is -6, -3, 0, 3, 6. And actually, while I'm thinking about this, back in another problem like this, we never identified the range. We found the domain, we did not then identify the range. If you were thinking, what the heck was that thingy? Well, good thought. Let's do it now. The range is just what are the y values that matched those x values. So my range in this problem, this was example 3, my range in this problem is, so range is -5, -3, -1, 1, 3. 1, comma, 3. It's just my y values. That's what the range is. Range are the outputs. Whenever you did the function, what came out of it? That was it. Okay? So now we're prepared to do number 7. So we're going to use this function -1/3. And I'm going to take my x value and plug it in. So that's -6. Magic calculator in my head works, but I'll show it out here. 1 divided by 3. This guy cannot do fractions, but if I take that times by 6, I get 2. So this math, this 1/3 times 6 is 2. And it will be positive because negative times negative is positive. So I get a positive 2 plus 2 equals 4. -1/3 times -3 plus 2. This is for the second one here. -1/3 times -3 is a positive 1. Plus 2 gives me 3. 0. If I take negative 1/3 times 0 plus 2, which that is just 0. Anything times 0 is 0, so 0 plus 2 is 2. Negative 1/3 times 3 plus 2. Negative 1/3 times 3 is going to be a negative 1. We add 2 to that, we're going to get 1. And negative 1/3 times 6 plus 2. Negative 1/3 times 6 is a negative 2. And we add 2, we get 0. So we're going to plot the point negative 6, 4. So from 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's my first point. Negative 3, 3. Negative 1, negative 2, negative 3. 1, 2, 3. 0, 2. Sideways 0, up 2. 3, 1. Sideways to positive 3, up to positive 1. And 6 zeros. Sideways to positive 6. 1, 2, 3, 4, 5, 6. Up and down to 0. There's my number 7. And let's do it right this time. Identify the range. Well, the range are just the numbers we got as our answers. It's these guys. So the range is 4. Ooh, what the heck is that? It's not a 4. 4, 3, 2, 1, 0. That was the range. Those are the y values we got when we graphed those x values. Okay, that's number 7. Number 8. It says, the presidential election of 1972 was the first election in which 18-year-olds were allowed to vote. The table shows the number, to the nearest million, of votes cast in presidential elections both before and since 1972. Explain how you know the graph represents a function. First off, okay, how do we know that this graph represents a function? Do you remember what a function is? A function says that for every input, for every x value, there's exactly one y value. Well, I do not have any x values being repeated, which means this will be a function because there's only one output for each input. There's no, for example, a negative 4 and a 93. If I had this, negative 4 would be going to both 73 and 93, and that would not be a function. So this is a function because each input has one output. Letter B, graph the function represented by the table. Okay, let's see here. I'm going to use a scale of 2's. So I'm going to count by 2's on x, and I'm going to count by 10's in y. Yeah, that'll work. Okay, so let's see. We need negative 12. So negative 2, negative 4, negative 6, negative 8, negative 10, negative 12 in x, positive 69, 10. Oh, 1, 2, 3, 4, 5, 6, 7. Ooh, counting by 10s isn't going to work. So 10s isn't going to work. How about 20, 40, 60, 80, 100? That'll work, I guess. So 20 in y. Okay, so I was over here in x. 20, 40, 60, 80. And we're looking for like something about 70. So we're looking for that point right there. That's this first one. And then the second one goes, we go to negative 8. So negative 2, negative 4, negative 6, negative 8. And then up to 71. So 20, 40, 60, 80. 71 is going to be almost about the same. I'll put a little bit higher. And then negative 2, negative 4. Up to 73. About the same again. 0 up to 78. Remember, this line has 80. 4 to 4. We're up to now 82, so we got bigger. 2, 4, 6, 8. We're up to 87, almost halfway there. And then 2, 4, 6, 8, 10, 12. We're up to 93. So we kind of get this slowly increasing line. Graph the function. Oh, we did that. So check, check. Describe any trend in the number of votes cast. Well, the trend I'm seeing, what's happening from one year to the next, well, each year there's more and more and more and more and more. It's going up slowly each year. So each year the number of votes cast, yeah, I can spell votes, V-O-T-E, votes cast increases. I mean, there's nothing more I can say than that. It's increasing by a little bit each year. It's not increasing by the same amount, because here it goes up by 2, and then by 2, and then by 5, and then by 4, and then by 5, and then by, what's that, 6? So it's not going up by the same amount each time. So the best I can say is each year the number of votes casts increases. Okay. So the summary box on the bottom of the note sheet asks you, how do you plot points on a coordinate plane? Answer that question quickly. It should only take about a sentence. How do you plot points? How did we plot all of those points, and all of those points, and all of those points? How do you plot points on a coordinate plane? Okay. You should have something like the x coordinate tells you how far to move left and right. The y coordinate tells you how far to move, up and down. So 3, -4, you'd go 3 in x, -4 in y. And the homework. It's helpful if you have some graph paper handy, because this homework comes from page 209, numbers 1 through 23 odd, and number 37. Some of those problems you will have to graph points, you will have to graph tables like we've done, but that is the homework. Thanks for watching. This has been Mr. Henry. Goodbye.